I love the nephron. The nephron is, you actually have 1 million of them in each kidney, which means there are a lot of them inside here. So what I'm going to draw you is extremely big, blown up, biggerified. Okay, but I'm drawing it for you here so that you can see, you can have perspective about where these nephrons are located. Then I'm going to show you a picture of someone else's drawing of a nephron, and then we're going to draw one ourselves. So nephrons are like these little, these little structures that almost look like little lobster claw things that have dipping, and they're tubules. And then they feed into collecting ducts, and there's like jillions of them in here. That's good enough. If you imagine jillions of them, then you kind of get an idea of how this looks. But I just wanted to place a nephron on the kidney, what you already know, so that you have some perspective of how this is going to work. Notice that my, that little line thing that I drew that, well, we'll talk about that in a second. Okay, so let's see what somebody else's drawing of a nephron looks like. Remember, I started my nephron in the cortex of the kidney, and I threw this big loop-de-loop down into the medulla of the kidney, and then I had this long line that I tried to make go all the way out to the renal papilla. And look at my renal papilla. It's got all these holes. It looks like a colander, and that's because all of these pieces of the nephron are gathering together and dumping basically what is at this point, by the time it comes out of here, we can call it urine. So let's draw ourselves a picture of a nephron and make sure that we can label all the parts. This would be a phenomenal quiz question. Draw a nephron and label all the parts. All right, are you ready? I'm going to draw my nephron like a tube because guess what? That's what it is. It has a hollow center. Now, we're going to spend a nice chunk of time talking about this part of the nephron. That thing, I sliced my nephron down the middle. This part of the nephron is called Bowman's capsule. That says Bowman's capsule. And it's actually like a cup, kind of like a funnel. And you'll notice that it has 2 layers. The plot thickens. There is a portion immediately connected to Bowman's capsule. There is a super convoluted part of the tubule called the proximal convoluted tubule. We're going to talk about the histological characteristics of each of these parts of the nephron. The structures of these nephron parts are linked to their functions. The proximal convoluted tubule flows into a structure called the descending loop of Henle. Whoa. This is the descending loop of Henle. And I wonder if they're going to make us rename that thing because I'm sure Henle is a guy, right? Holy crud. The descending loop of Henle becomes, that's kind of crazy right there, but it becomes the, what do you think this is? Ascending loop of Henle. Ascending loop of Henle. This kind of tells you the direction that fluid is going to travel, and in fact, it's true. Fluid travels in this direction. The ascending loop of Henle eventually, now I have to draw something else for you. We have to make note that these structures, Bowman's capsule, proximal convoluted tubule, are in the cortex of the kidney. the loops of Henle dip down into the kidney. Once we get out of the cortex, out of the medulla, we have another like zone of, that looks like this. What do you think this is? It's another convoluted tubule. This is the distal convoluted tubule. The distal convoluted tubule, it's a little unfortunate that they use distal and proximal because they have nothing to do with limbs. Proximal close to Bowman's capsule, distal farther away from it if you follow the tube route. That's cool. And then distal convoluted tubules dump into collecting ducts. Collecting duct. Collecting ducts, there are distal convoluted tubules from 1 million nephrons that dump into collecting ducts. And the collecting ducts converge and converge and converge and eventually form little holes, little pores in the renal papilla. And so whatever is left in the collecting duct, by the time you get to renal papilla land, whatever drops out is going to be your urine. So this is heading to renal papilla. That's where it's going to exit. The fluid that's inside here, when it dumps into the renal papilla or it gets to the renal papilla, where is it going next? It's going to fall into a minor calyx. So this totally fits in with our gross anatomy. It's just the zoomed in version. There's something really important that I haven't included in this picture yet. And think back. What's the purpose of the kidney? The nephron is the functional unit of the kidney, and the purpose was to filter the blood. So does it make sense that we're going to need a blood supply here? And in fact, inside Bowman's capsule is a net of capillaries. So take a look at this bad boy, because this is a giant net. Look how giant this is of capillaries. And if you look at this, we have an incoming vessel. This incoming vessel is called the afferent arteriole. And we have an outgoing vessel, and this is called the efferent arteriole. And then this, now I can't draw it very well, but really if I were going to do this justice, it's like a tangle of capillaries. And we know that capillaries are the site of gas exchange, and we know that every cell has to come in contact with a capillary. This is our next example of a portal system. This net of capillaries is not designed for gas exchange. This net of capillaries is fully set up to filter the plasma in the blood and get the plasma out of the blood and into Bowman's capsule. So what ends up happening is that plasma from the blood is filtered out. Now, just for perspective, and I'm going to try really hard not to tell you all the cool things that are true about this because it's so cool. You filter out 180 liters of fluid flows into your nephrons every 24 hours, which is like stupid, crazy, huge amount of fluid. 180 liters? You pee out 1.5 liters every day. So obviously we reabsorb all of it, almost all of it. What you filter out, 180 liters, is going to pass through the nephron, and as it passes through the nephron, we're going to reabsorb it. We reabsorb 178.5 liters of what we filtered out from the glomerulus into Bowman's capsule. I didn't write glomerulus down, but did you know that, did I say that already? Nobody knows. Glomerulus, which is the knot of capillaries. Okay. Man, the nephron's cool. In the next section, we're going to look at the Bowman's capsule plus glomerulus, which makes the renal corpuscle. So we're going to name some parts in this area.